Hi everyone. Okay, so one last example from 4.4. We want to solve the differential equation y double prime plus y equals sine x plus x cosine x. So the first step is to solve the homogeneous version to get the complementary solution. And you can see I already started that. The homogeneous equation is y double prime plus y equals 0. Ignore this little 1 here. And so the auxiliary or characteristic equation is m squared plus 1 equals 0, which has two solutions, plus or minus I. And we know when we see an imaginary solution to the auxiliary equation, the complementary solution will be oscillatory, right? Sines and cosines. So C1 cosine x plus C2 sine x. Okay, so once you have the complementary solution, now you look for your particular solution. Your particular solution here, well, is going to contain sines and cosine functions, right? So this could be a little tricky. Ordinarily, what would we guess, right? So if we knew nothing about the complementary solution, our guess would have to be a sine x, although remember that's going to also involve cosine functions. So let's start with a cosine x plus b sine x, right? And then, since we have x cosine x, now we need a cx cosine x plus dx sine x. Okay, so that would be our guess if we knew nothing about the complementary solution. However, the complementary solution also contains sines and cosines as well as the particular solution. That's a conflict, so we can't have that. So what are we gonna do here? Well, we're gonna have to multiply this whole thing, the entire particular solution here, by whatever eliminates the duplication, right? So in this case, I think if we multiply all this by x, like that, then that eliminates the duplication. Does that sort of make sense here? Right, because here we're going to get cx squared cosine x. Here we're going to get ax cosine x. But we don't have a term with just cosine x anymore. So that should do it. So what I'll do, of course, is just multiply all this out. So we're going to get, let's see, I think it's, all right, so ax plus cx squared cosine x, and then bx plus dx squared sine x. Okay, so that's our particular solution, that eliminates the duplication in the complementary solution. All right, so now what do we do? Well, now we have to take the two derivatives, the first and second derivative, and plug them into the left side here. So obviously we don't need y prime because it's not in the homogeneous part. However, we do need y double prime, so let's just do one at a time here. So this is not going to be pleasant, but let's start with yp prime. So I guess that's going to involve the product rule here. So first times derivative of the second, so that'll be negative ax plus cx squared sine x, and then second times the derivative of the first. So the derivative of the first is a plus 2cx times, cosine x, yep. All right, and then do the same thing here. I hope I don't run out of space. So I think first times the derivative of the second, so cosine times bx plus dx squared. All right, and then plus second times the derivative of the first, so that's just going to be b plus 2dx times sine x. Okay. Right, I'm just wondering, I think we can go one step further here. Let's combine this sign and this sign. Well, let's do the cosines first. So yp prime is going to be, let's see, dx squared right? Plus 2cx plus bx, so that's going to be b plus 2c times x, and then plus a, all times cosine x. Yikes, right? All right, and then we have, that's an x. For the sines, we have the x squared term, cx squared. We have it's negative. Oops. So negative cx squared. And then we have 2dx minus ax. And then we have, let's see, a plus b, all times sine x. Great. Okay, and that's just the first derivative. So now, hopefully I don't run out of space again. So now we can take the second derivative, and we just do this all over again. We have a product rule here. So first times the derivative of the second. So all of this times negative sine. I'll put this up front here. So, yep, so just copy this down. Dx squared plus b plus 2c times x plus a, right? And then cosine times the derivative of all this. So that's 2dx plus b plus 2c. Right, and the derivative of a is 0. All right, now we do it with this term. Okay, so we have sine times all of this. Let me just write it underneath here. So plus sine times negative cx squared plus, that's a d here, right? Minus plus 2d minus a times x plus b times sine x. So I just realized I didn't take the derivative. Oops. All right. There we go. So what's the derivative of all this? It's going to be negative 2cx plus 2d minus a. Okay. And the derivative of b is 0. Okay. So I did, the derivative of the first times the second plus the second times the derivative of the first. Wait, I just did that. Sorry about this. So cosine, derivative of sine is cosine times all this. Okay, good. So we have plus cosine, and then just copy this down, minus cx squared plus 2d minus a times x plus b. Phew, all right. Now putting this all together, this should be the second derivative. If it's okay with you, I'm going to put the cosine first. And so inside here we have negative 2, negative cx squared. I think that's the only squared term, right? Oh, gosh. So bear with me, I'm still learning how to do this. All right, so negative cx squared. And then we have plus 2dx plus another 2dx. I think that's 4dx. So 4 times d. And then minus a times x. Yep, that's still there. And then, let's see, plus b plus 2c. So all of that times cosine x. Great. So now let's do all of this times sine x. We still have the dx squared. All right. And then the x terms, well, we have, let's see, we have 2cx minus 2cx. Hang on. This is minus sine x. Oops, so that's going to be minus d squared. Yep, these don't cancel, right? Minus 2cx is minus 4cx. And then we also have a minus bx. So times x. So let's see, can I factor out the negative here? Times x. And then we have, let's see, 2d minus a minus a. So 2d minus 2a. 2d minus 2a. I think it was a plus 2d. Oh, I hope this works. So times sine x. All right, so I'm second guessing myself because this is 2d minus 2a, and going back to this, the cosine here we have b plus b, so this should be a 2b here, plus 2c, yep, 2b plus 2c, phew. All right, so that's our second derivative, that's our yp second derivative, right? So now we just add that to the original yp up here, and that should equal x, sine x plus x cosine x. So, all right, let's see if that works. All right, so let's write the left side of the equation is yp double prime plus y. All right, so let's start with the cosines. We have cosine and then this cosine up here for the yp. So combining everything, we get minus cx squared plus cx squared. That's convenient. And then we have ax minus ax, 0. And then we have 4dx. Oh, I wrote this down. Let's write the rest down. So minus ax from yp double prime, and then plus ax from yp. Okay. So that's 0. Okay, and then we have the 2b plus 2c. So that's still there. This pen. 2b plus 2c. So that's all times cosine x. And then the sine function. So we have minus d squared plus d squared. That's 0. And then we have the x terms. So we have minus 4b x. Sorry, I think that's minus 4cx. Minus bx. And then originally we had plus bx. I think that's it. Oh, I didn't write down that the d squared minus dx squared minus dx squared. All right. And then the constant only comes from here, 2d minus 2a. All times sine x. All right. So, yes, these end up being 0. These end up being 0. And these ends up being 0. And, of course, I had a minus dx squared plus dx squared I forgot to write down. But all of this should simplify to, let's see, we have 4dx plus 2b plus 2c times cosine, right, plus, and then negative 4cx plus 2d minus 2a, all times sine x. Okay, so what does that equal? Well, on the right side we have sine x plus x cosine x. Okay, so now just matching the terms from the left and the right. Move this down a little. So let's see, x cosine x. So all of this should equal x. So we have 4dx plus 2b plus 2c just equals x. So that tells me that 4 times d has to be 1, and 2b plus 2c has to be 0. Right, now let's look at the sine term here. The sine, all of this, minus 4c x plus 2d minus 2a, that should equal, well, 1. Right, so that tells me that negative 4c equals 0, and 2d minus 2a is equal to 1, right? So that tells us that c is 0. It tells us that d is 1/4 right away. And, well, if d is 1/4, 2 times d, I could put it over here, 2 times d is 1/2, minus 2a equals 1. And so negative 2a is just going to be 1/2, which means a is, I think, negative 1/4. And finally, 2b plus 2c. So c was 0, right? C was 0, so 2b equals 0, which means b is 0. Okay, so I think that gives us our particular solution. You can see I'm running out of space here. All right, so let's write down the particular solution. I got to go way up here now. So ax plus cx squared. Let's write this down here. Ax plus cx squared. I believe it was cosine. Yep, cosine x plus bx plus dx squared times sine x. So plugging in the numbers, we get, let's see, negative 1/4 times x times cosine x plus b is 0 and d is 1/4, so 1/4 x squared times sine x. And that's our particular solution. So all you have to do now is, to get the general solution, add this to the complementary solution. I guess I'll do that, squeeze that in here. So your final solution should be c1 cosine x plus c2 sine x minus 1/4 x cosine x plus 1/4 x squared sine x. Phew, that was a long one. And I hope I got it right. So I think that's right. If any of you find a discrepancy, or if you see I did anything wrong, let me know. But I think that solves the original differential equation. And of course, you can check, right? If you take the second derivative of this, plug that in here, everything should work out. But that would take up a whole nother video. So I'll leave it to you to make sure that this is correct, but I'm pretty sure it is. All right, well, I hope that helps. And again, this is about as bad as it will ever get. I wouldn't even expect anything like this on a test, but the one we did before this, I think, was reasonable. So I hope that helps.